All right, so with Mountain Math, our goal is to be able to complete questions 1 through 12. 8 is going to be your doozy. It is a word problem, but it also consists of fractions. Families, I'm going to reach out to you on that one and sit with your child and walk them through if you have the time to do so, of course. I challenge you to give yourself a chance to do the best that you can on number 8. All of the other problems, comparing number 12, we're comparing fractions. We have the tools to compare those fractions by trying to find equivalency, and we'll go over that in just a bit. But basically, if kids can put 11/15 and 12/20 into simplest form, we will be able to determine whether or not these fractions are less than, greater than, or equal to each other. Sorry, I just stepped on my kitty. All right. Excuse me. All right, so what I'm going to be doing is toggling between two different screens. This is the Mountain Math screen and also our document camera, which is where we will be putting the numbers for, which will be putting the numbers from 1 through 12 on Mountain Math onto this document here. There's the front and the back and another front here. Okay, all right. So let's look at number 1. Number 1, our numbers are 32,576 and 32,756. So we can go ahead and start writing those numbers down. 32,756 and 32,576. Okay, and so at that point, you guys are going to determine whether or not the number is even or odd. You're going to write it into word form, put it into expanded form. That's your place value, positions, the value of each digit depending on where it is in the number. So 30,000 plus 2,000 plus 700 plus 50 and plus 6. 32,756. Okay. And then this is an opportunity for some mental math, adding 100, subtracting 100, multiplying by 10, 100, and 1,000. Students have been engaged in routines with these problems, these types of problems, so that it becomes a mental math strategy when adding, subtracting 100, or multiplying by any multiple of 10, really, but in this case, 10, 100, and 1,000 specifically. And then you get to compare the two numbers, how many ones are in the tens place, how many tens are in the hundreds place, how many ones are in the tens place, and how many hundreds are in the how many ones are in the hundreds place. These questions right here can be tricky. They are often overthought, but if your child is having a hard time with those questions, don't worry about it. Just have them, kids, persevere through these problems, and don't let it stump you. Okay, if you have to draw a picture, draw a picture. Okay, number 2. Our number is 138,290. excuse me. So when you're writing this number here, just write it above in this particular space right here, okay? 138,290, okay? And then there are all of these operations, you know, what's the value of the 8, what's the value of the 3 because of where it is in this particular number. What is this number when we round it to the nearest tens, thousands, and millions place. Okay. All right. Number 3. Number 3 is 35. Okay. Is this number prime or composite? Well, I'm going to bring you over here right quick. And we have this poster here, prime or composite. You know, in red are some of our hints. The number 1 is neither. The numbers 2 and 5 are prime. And all even numbers are composite except the number 2. Okay, so those are some hints for you to get you through number 3. I will also go ahead and post that picture of that chart to our class dojo. Is the number prime or composite? In order to figure out if it's prime or composite, you don't need to create the factor tree, but you do need to list the factors of 35. As factors is the key word in this direction here. Determining prime or composite depends on the factors that make up the number, in this case 35. So we can go ahead and list out what are the factor pairs of 35. We have, of course, 1 times 35, okay? And we have 7 times 5, okay? And now we can go and we can list the factors. We have 1, cross it off. We have 5. We have 7. And we have 35. What I just did there is a strategy to help prevent kids from forgetting factors, making unnecessary errors that might get in the way of putting fractions into simplest form once we get there. So because 35 has 4 factors, it is considered a composite number, remembering that prime numbers only have factors of 1 and themselves. Okay, I'm ready to move on. We're trucking right along here. A few of these problems, they are a bit longer. I will, in an attempt to keep the video shorter, I will assume that you guys are going to be able to complete these problems independently to the best of your ability. Okay, so number 4, we have the numbers 16 and we have the number 15. Okay, so switching back over to the document camera, I'm going to turn the page, and on the back, the first number is 15 I should say, and the second number is 16. I am going to have you think of these two numbers as they are right now. Think of them as a fraction, okay? Think of them as a fraction, 15/16 that we're trying to put into simplest form, okay? Kids, what we're thinking about here is first, what is our direction? What's our first direction here? It says list the factors of each number, okay? Then it says circle the common factors, put a square around the greatest common factor, all right? So of course we know in our routine that in order to list the factors, we've got to first put the factor pairs. So for 15, The first factor pair that comes to mind is 1 times 15, and 3 times 5 is that second pair. In these situations, when you're listing factor pairs, you do not need to list the commutative property. So you do not need to list 15 times 1, and you do not need to list 5 times 3, as they contain the same factors, and we don't need to repeat the factors when we are listing them up here for the first and second number. So now we're ready to list the factors for 15. We have 1, we have 3, we have 5, and we have 15. Okay, just cross those off, just sort of letting us know we took care of those. Now for 16, the first factor pair, 1 times 16, we have 2 times 8, and we have 4 times 4. All right. I do want to remind you, as these factor pairs are coming to my mind swiftly, kids, you may not be in the same boat, and hey, that's okay. We're striving to get there. But I do want to remind you that inside of your lovely yellow folder that has all your usernames and passwords, you have a multiplication table that goes to 15 times 15. This will be very beneficial to you when listing factors and locating multiples once you get there, okay? So make sure that you pull that out when you're completing even numbers, number 3 as well. Okay, I'm gonna stick this back into my folder. Now I can go ahead and list the factors. Notice that we have a double here, 4 times 4. Watch what happens. So I'm gonna list 1, I'm gonna list 2, I'm gonna list 4 only once. I do not need to list that second 4. I'm gonna list 8, and I'm going to list 16. All right, so we just did direction number 1. We listed the factors for each number. Now we can take a look at the second direction, which is circle the common factors. As we go through, we can see that both 15 and 16 have the number 1 as a factor. And as I scale down the list, there's a 2, there's a 4, there's an 8, there's a 16, there's a 3, there's a 5, and there's a 15. Those are the only common factors that we have for the numbers 15 and 16. So now the second direction is put a square around the greatest common factor. Okay. Well, the square is, in fact, is that a square? Yeah, that's a square. Is 1. So 15/16 is in simplest form because 1 is its greatest common factor. If you divided 15 and you divided 16 by 1, of course you would end up with 15/16 again. So how many common factors did we have? We had 1. That was a very anticlimactic number 4 right there. As we move through more Mountain Math activities, we will come to a much more exciting version of that problem there. All right, number 5. We are going to locate our 2 numbers we're going to be working with. Notice how I spent a good amount of time here on number 4. This is where we left off. Our last math lesson was the idea of how do we find out if fractions are equivalent. And that's where this poster came in handy. So as you are looking at IXL, you know, making and finding equivalent fractions was the topic that we were talking about last. You know, we have our fraction strips, which are inside of your yellow folder, using number lines. Number lines are a little more tricky. Great practice within IXL for that. And multiplying the top and bottom number by the same factor, or dividing the top and bottom number, also known as the numerator and denominator, by the same number, also known as the greatest common factor. Okay, so this is where we left off. There's some great problem solving within the skills of fractions. Okay, number 5, our numbers are 2 and they are 8. Okay, so we are going to switch back over. We have the numbers 2 and we have the number 8. List the multiples of each number on the number line. At least 8 multiples. Kids, this is where your multiplication chart can come in handy. As when you are listing multiples, you are basically skip counting by that number. Skip counting by 2, skip counting by 8. Find your 2. All of your multiples are inside of the multiplication chart. So factors are the factories that make the multiples, okay? And you could do the same thing for 8, okay? I'm gonna move on from that question there. Let me know if you have any questions with any of the problems that I do skip. Okay, number 6, our numbers are 5, 10, and 15. In this case, we're gonna be locating a pattern. What I like for the kids to do is write the first 3 numbers up here. And then as they continue the pattern down here, they can list more options or have more opportunities to continue the pattern. If they list 5, 10, and 15 down here, then there's only 2 opportunities to continue that pattern. And so I have them write it up top here. All right. So what's the pattern rule? Okay. How are the numbers changing from 5 to 10 to 15? What are the features? Features, kids, remember, these are the ideas of numeric and non-numeric features of a pattern, okay? And then it asks to extend even further into the 10th and the 15th, okay? Number 7. And if you're already feeling good, just pause at one of these points, fill in all your numbers, and some of you are ready to go to town on this. So you could just pause at this point, or even earlier on in the video, maybe you already did pause, and you can begin completing problems 1 through 12. This is just a walkthrough, as this is a routine that I really don't introduce into the classroom until about February or early March. In this case, this year, we introduced it early March. Our numbers for number 7, 20 is 5 times as many as what? So we are looking at this problem as 20 is 5 times as many as, well, 20, the word is similar to equal. So 20 is equal to what? Well, 20 is equal to 5, the number 5 multiplied by some number. It's not necessarily the multiplication, but it's taking the word form and applying it to the equation that you have to create based on what the words say. So you're working backwards in this instance. 20 is, or equal to, 5 times as many as what? So what is the missing factor? And I would like you to draw the array down here in the space below. All right, number 8. Number 8's a doozy. We spend a lot of time on number 8. Number 8 could take some of us upwards of 2 and 3 days by, spending 10 or 15 minutes. And so if you don't get it solved in the first day, that's okay. Allow yourself the patience and the time to complete this problem. Again, this is uncharted territory. This is sort of a preview of what is to come. So we have Gus, we have Hal, and we have Dex. They need 10 3/4 feet of rope to finish their tree house. Gus found 2 4/5 feet at his house. Hal found 3 7/10 feet in the garage, and Dex bought 4 feet. How much rope do they have all together? Do they have enough to finish the tree house? how much more do they need, or how much do they have left over? Okay, so what I'm gonna do is because there's so many details, I'm just going to write down these details with the screen up, and then I'll show you the what will I show you? I'll give you a little sneak peek into the answer to this question. I will not answer this question for you. So we have Gus. Okay, and this is using cubes, kids, right? So circle the numbers, underline the question, and in this case, underline the 3 questions that are in here. And after underlining the questions, you can start to solve by putting boxes around any clue words. So the clue words in this case would be, Gus and Hal and Dex and what they have. So Gus, he has 2 4/5 bits of rope. Then we have Hal, and Hal has 3 7/10 feet in the garage, and our buddy Dex. Dex has exactly 4 feet of rope. Okay. At the end of the day, what do they need? They need 10 3/4 feet of rope. Okay. How much rope do they have altogether? Do they have enough? And how much more do they need, or how much are they going to have left over? So a little clue word you can jot down for you to remember what those questions are is you all together. Okay. Then the question of enough. A little question mark. And the final question, need or leftover. Okay, and so what that looks like on your Mtn Math form could be something like so. So we have Gus, he's got 2 4/5 feet of rope, 3 7/10 feet of rope from Hal. Oh, Dex has got 4 feet. They need 10 3/4 feet to finish that tree house. And then you have your 3 questions. How much do they got all together? Do they have enough? And how much do they need? Or how much do they have left over? One thing that you can start by doing is simply adding up the whole numbers. So the whole numbers are your 2, your 3, and your 4. And if you add those up, 2, 3, and 4, that's going to get you a solid 9 feet of rope. Okay, they need 10 3/4. So do we have 1 3/4 worth of rope tucked into our fractions? Okay, so 4/5 and 7/10 are the fractions that we're dealing with. Okay, or that would look like 4/5 plus 7/10. And in order to add these fractions, you've got to be able to locate a common denominator, simplest form, or least common multiple can get you there to locate a common denominator. And so the least common multiple, right? So if you're listing the multiples of 5, right, you have 5, 10, 15, 20, 10. You have the multiples of 10, 20, 30, right? So we have some common ones. We have 10 and we have 20. What is the least common multiple here? And I'm sorry, that's terribly small. I hope that your computer monitors and or your Zoom capability is there for you. So in finding the least common multiple, we can now start to create a common denominator. Okay, so when we're looking at a common denominator of, or excuse me, a least common multiple of 10, well, what do you got to do to 5 to make 10? Well, multiply it by 2, right? And then what you do to the bottom, you got to do to the top. Okay? What do you do to 10 to make 10? You multiply it by 1. What you do to the bottom, you got to do to the top. So now we can get a common denominator, and that common denominator is going to end up being 10. So our two new fractions that we have that we're going to add together, and I'm going to make a little workspace over here for us, is 4 times 2 is 8, and 5 times 2 is 10. I'm going to use this as my fraction line. Plus, I have 7 times 1 is 7, right? And 10 times 1 is 10. Now I can add those fractions together. And remember, this is all to figure out, do we have 1 3/4 worth of rope tucked into the fractions of 4/5 and 7/10? We end up with 15/10, okay, when we add these two fractions together. 15/10 is an improper fraction, okay? 15/10 is an improper fraction. So we need to convert that to a mixed number, okay? This is beyond what we have done in the classroom. Or taking an improper fraction where the numerator is larger than the denominator requires thinking about this. How many times does 10 go into 15? Well, 10 times 1 is 10. 10 times 2 is 20. 20 is too big. It only goes one time, okay? Well, if 10 only goes into 15 one time, 10 times 1 is 10. And how many are left over in order to get to 15? 5. 5/10. Okay? Now we have 1 5/10. We need 1 3/4. Okay? Now, I know that 5/10 is equivalent to 1/2 because 5 is half of 10. Also, I could figure out that 5/10 is equivalent to 1/2 by looking at my fraction strips. If I find 5/10 on my fraction strips here, I see 1, 2, 3, 4, 5. 5/10 here, and if I go up, it should line exactly up to the 1/2 space, and it sure does. So 5/10 is equivalent to 1/2. That's me putting 5/10 into simplest form. 1 1/2. We have our 1. We need 1 3/4. Now it's comparing 1/2 to 3/4. And from there, I'm going to let you answer that question. How much do they have all together? Okay, that's somewhere over here. Do they have enough? And how much do they need, or how much is left over? And in order to do so, compare 1/2 to 3/4. If 1/2 is less than 3/4, you know they don't have enough. If it's greater than, they have too much. If it's equivalent, they got just the right amount. But from here, you can use your fraction strip paper to compare these two fractions to find out if they have altogether enough, need, or leftover. If you stopped this video and solved this problem on your own, and you found a way that you have solved this problem, or mom and dad, you have solved this problem and walked your child through, send that video. And if you're okay, we can post that kind of stuff so that families can get multiple interpretations. The one thing that's missing from all of this is exactly that. We need to remember that in the classroom, your kids are constantly talking to each other, whether it's on task or off task. Kids, you're constantly talking to each other. And by talking to each other, you are allowing yourselves to share ideas. And in an focused, directed conversation in the classroom, you guys would be talking about your journey to get to the end of this problem. And through virtual learning, this is the gap that I am noticing. And that gap's going to get bigger unless we start to tap into Zoom. And I haven't gotten a whole lot of feedback on whether or not you have access to Zoom. And so I do want to host a Zoom lesson this week, but there aren't many of us out there. And so without the face-to-face contact and without the conversations, a lot of the learning is gonna be a bit more difficult because you're not gonna be able to share your ideas, the excitement of learning and sharing your responses, whether they're right or wrong, is what gets the blood flowing. And so if you have a journey that you took, you got an avenue for getting to the conclusion of how much do they have altogether? Do they have enough? Do they have any leftovers, or what do they need? Send that to me. And if you're okay, I'd love to post it, because that's a way that we can create a dialogue. And that dialogue can be accessed in a video rather than having to join into a Zoom meeting at any particular point in time in a day. So, number 8's a doozy, and it always is a doozy. Okay, this video is getting a little too long right now. I like to keep them at about 30 minutes. I will turn on over the next few, adding and subtracting, multiplying and dividing. These are the skills moms and dads, grandmas, grandpas, aunts and uncles, family members, all out there. Everyone doing an amazing job of taking care of each other out there. These are the problems that really need to be focused. You really want to look over your kid's shoulder and see how they are doing on their own with problems 9 and 10. So the numbers for 9, we have 12,500 and 299. I'm going to go ahead and write that down. 299. We'll add it, and then we'll also subtract it. Okay, and then we have, for number 10, the numbers 408. So 400 times 8 and 400 divided by 8. And that translates to that on your form. Okay. Earlier I was talking about mental math and multiplying by multiples of 10. That is these right here. So 400 times 8. 400 is a multiple of 10. So is 40. Using that mental math strategy of, if 40 times 8 is, or 4 times 8 is the basic fact, whatever you get there, just plug back those two zeros. And then 400 divided by 8. There's not a whole lot of room in here. If you need to use scratch paper to extend your long division down, by all means, please do so. Okay. Number 11. We have the missing number within an expression. Or within the equation. So 1034 minus the unknown is equal to 1000 minus 2 plus 32, and that is eked in there. Not a whole lot of space for number 11, but 1034 minus the unknown is equal to, and that equal sign is on the outside of these parentheses, sorry. 1000 minus 2 plus 32. So kids, here we're thinking about order of operations. You see parentheses there. And so what are you going to do first? I suggest you figure out what is the value of the right-hand side of the equal sign, and then you can take that and figure out what the missing number here is, or subtrahend, from 1034. So what are you going to take from 1034 in order to make it equal to the right-hand side of the equal sign? You can see 1000 without that minus 2, that would be 1032. So it's going to be 2 less than 1032. And what are we going to need to take away from 1034 to make both sides of the equal sign the same? That was me holding my hands like a scale. Yes. All right. Number 12. We have 11/15 and 12/20. Zoom on out. The word zoom is just going around everywhere, huh? Even without the technology. I think I say zoom a lot. 11/15 and 12/20. You want to take these two fractions and put them into simplest form, okay? By doing so, you may or may not be able to use your fraction strips because I'm looking at 11/15 and 11 is a prime number. So the only common factor between 11 and 15 is gonna be 1, so that one stays the same. 12/20 is a little bit different. But we are trying to figure out, are the fractions equivalent? And if not, okay, it says make them equivalent. Okay, so what are you going to need to add to a particular fraction or subtract from a particular fraction? That's a doozy. But because we left off with fractions, I would like you to persevere with fractions, trying, exploring, carrying with you that growth mindset, that, hey, right now it's okay if I'm getting these problems wrong, but at least I'm playing with fractions, I'm drawing pictures of fractions, I'm looking at them, I'm saying them. So many benefits from just having a conversation about fractions, and not necessarily getting the correct response, but at least you're starting a conversation about comparing fractions. So that is Mountain Math in a nutshell. I do anticipate a few questions on this, so please, families out there, kids, if you guys have questions about any Mountain Math, please let me know. And I am available to Zoom with you by email. So just send me an email, send me a Dojo message, and we can get in contact. All right, boys and girls, have a great day. Stay strong, and I hope you enjoyed yoga with Mrs. Tillish. She was very excited to be able to do that. All right, it is 9:48, Monday, March 30th. All right, wonderful day to you.